You're scrolling online and some headline just grabs you, maybe feels a bit off. It's getting really hard to tell what's what these
It
days.
really is. Just the sheer amount of stuff online.
Yeah, and misinformation, it just spreads so fast. Traditional fact checking, trying to do it manually, it just can't keep up.
No way.
Hmm.
The speed and scale are just overwhelming. And it affects, well, everything, how we see the news, even health choices sometimes.
Which is exactly why we're doing this deep dive today.
Yeah.
You sent over some really interesting research about using generative AI to help fight this, not just flagging things, but giving actual explanations.
Right.
So our mission today is really to unpack how these AI tools work to, help sort fact from fiction.
Exactly. The material covers a really potent mix of AI techniques.
Mm.
We're talking text embeddings first, basically teaching computers to grasp the meaning behind the text.
Okay.
Then vector stores, specifically one called FAISS, which are like super fast search engines for those meanings. And finally, Retrieval-Augmented Generation, or RAG. That uses large language models, LLMs, to create fact-checked answers based on actual evidence.
And the research, it actually showed this in action, right? Using a real data set, the ISOT fake news data set, and OpenAI's GPT models.
That's right. We'll look at how this tech combo can find relevant fact checks really quickly and then generate these clear, simple explanations for anyone trying to make sense of it all online.
Okay, let's start with text embeddings. Teaching computers meaning sounds a bit abstract. How does that actually work for spotting bad information?
Well, think of it like this. Embeddings turn text words, sentences, whole articles into numbers, vectors. The clever part is texts with similar meanings get vectors that are mathematically close. Libraries like sentence transformers have pre-trained models that are really good at creating these, let's call the meaning fingerprints.
So, like a unique ID based on what it's actually saying, not just the words.
Precisely.
That's smart. So, two articles pushing the same fake story, maybe worded differently, they'd still have similar fingerprints.
Exactly that. And that lets us measure semantic similarity, which is vital because a fact-check article debunking something might use totally different language, but the core, meaning like, this claim is false, here's why, would be close in that embedding space.
Okay. So we have these meaning fingerprints for tons of articles. But how do we search through them quickly when a new claim appears?
Yeah.
That's the vector store, the FAISS thing. Sounds like finding a needle in a haystack otherwise.
You nailed it. Imagine millions of these fingerprints. A vector store like FAISS, which stands for Facebook AI Similarity Search, is built for exactly this scale. It indexes these high-dimensional vectors incredibly efficiently. Think of it like a super organized library, but instead of Dewey Decimal, it arranges things so you can instantly find related concepts.
Right. So a new claim comes in, we make its fingerprint, and FAISS finds the closest matches from our fact check database almost instantly, like a super fast related content search based on actual understanding.
Exactly. And that naturally leads us to our Retrieval-Augmented Generation. So we've used the embeddings in FAISS to grab similar articles, hopefully including some solid fact checks. Now, we need the AI to generate an answer, but crucially, an answer based on the evidence we just pulled up. That's where the LLMs come in.
Right, the large language model. So the LLM looks at the original claim and the relevant stuff we found with FAISS, and then explains the connection, synthesizes it?
Precisely. It gets the user's query plus the relevant info retrieved from the vector store. And the prompt basically tells it, okay, here's the claim, here's related info with truth labels. Based on this, is the claim likely true or false? Explain why, using this evidence.
Ah, so it's retrieval augmented because the generation isn't just thinking on its own. It's directly using the facts we retrieved. That sounds like it would cut down on the AI just making stuff up, the hallucination problem.
It absolutely does. Significantly reduces that risk.
Yeah.
The answer is grounded.
So it's not just false. It's based on these specific articles that address similar claims. Here's why it's likely incorrect. That evidence layer makes it way more trustworthy.
Totally. And the research you shared also pointed out the specific tools, the Python libraries that actually, make this happen behind the scenes. Could you run through some of those?
Yeah, definitely. It looked like the key ones were sentence transformers for those meaning embeddings. LangChain seemed important for connecting all the pieces. And while ChromaDB got a mention, FaceGoo was the focus for that fast vector searching using the GPU power.
Right.
And then usual suspects, pandas, NumPy for data handling, Torch underpinning a lot of the AI models, and the OpenAI library for using their GPT model.
Exactly. And the foundation for all this is data. The ISOT fake news dataset was mentioned, which is great because it has articles already labeled fake or true. The first step is just loading those files, merging them, and importantly, adding that label so the AI knows which is which.
Right, like building a labeled library to train and test the fact checker. And once you have that labeled data, the next step is turning all that text into those numerical meaning embeddings we talked about.
Precisely. The demo uses a specific model, all MinLM L6v2. It's been trained on tons of text, so it's really good at capturing the essence, the semantics, and encoding it into these 384-dimensional vectors.
Wow, 384 dimensions. Sounds complex.
It is, but it captures a lot of nuance.
So every article gets this 384 number representation, and then we build the AISS index, the super fast library for these vectors.
That's the flow. FAISS organizes them for near-instant similarity search. So when a new claim comes in, we generate its embedding, and boom, FAISS finds the most similar articles from our labeled set, along with their labels.
Okay, so finding similar articles is sorted. Let's dig into the RGAG part more. Those functions mentioned, retrieve similar texts and generate explanation. What are they actually doing?
Okay, so retrieve similar text is the bridge. It takes the user's query, encodes it into an embedding, then asks the FAISS index, find me the top K most similar articles. Usually K is small, like 3 or 5. And critically, it also pulls back the original true or false label for each of those retrieved articles.
Got it. So for our vaccines cause autism example, this function finds the most similar articles in the dataset and tells us if they were originally labeled true or false.
Exactly. Then generate explanation steps in. It gets the original query and that list of similar articles with their labels. It then builds a prompt for the LLM. Basically says, user asked this. We found these related articles labeled thusly. Based only on this evidence, is the claim likely true or false? Explain concisely, referencing these articles.
And in the vaccine case, it would probably find articles debunking it labeled true, perhaps if the article itself is factual in its debunking, or maybe the original source was labeled false. The LLM, say GPT 3.5 Turbo, would then explain why the claim is likely false, citing those retrieved pieces. That's way better than just a binary answer.
Much more robust, exactly.
Yeah.
And the research also mentioned tweaking the output using something called few-shot prompting. What was interesting there?
Yeah, that was neat. It's basically showing the LLM what you want. If you need the output in a specific structure, like JSON with fields for label and explanation, you just include a couple of examples of that format right in the prompt you send.
Right, so you guide it. It helps get structured, predictable results back. Super useful if you want to automatically process the output later.
Makes sense. Okay, now things get really interesting when it shifts from static data sets to tackling, well, the fire hose of live news, using NewsAPI for recent articles and Google's Gemini model for analysis.
Yes, this makes the system dynamic, able to handle current events. NewsAPI lets you programmatically pull recent news articles on specific topics, like AI developments. Then the idea is to use a powerful LLM like Gemini to get a quick read on the likely truthfulness of those fresh headlines.
And you need API keys for both, right?
Yeah.
NewsAPI for the news feed, Google Gemini to use their model, like getting backstage passes.
Exactly. Once you have those, you use a function like Fetch Latest News to grab recent headlines on your chosen topic. Then Gemini Fact Check comes in. Initially, this just prompts Gemini with the headline and asks for an assessment, true, false, partly true, and a quick justification, even without feeding its specific external evidence yet.
So at first, it's kind of relying on Gemini's own vast training data for a quick gut check on a new headline. The research showed pulling AI headlines and getting Gemini's initial take.
Right. But, even great LLMs like Gemini aren't perfect. They might miss the absolute latest detail or context. That's why the next step is so crucial. Grounding Gemini with real-world context from Google Search. This really bumps up the reliability.
Okay, so instead of just Gemini's internal knowledge, we're giving it fresh info from Google search results to make a better call. That involves setting up Google Programmable Search, getting more keys, a search engine ID.
Precisely. Programmable Search lets you customize the search engine via API. The Google Search Snippets function uses this to grab the top search result snippets for a query, like the headline. You can even tell it to prioritize certain sites, like fact-checking websites.
Oh, smart. So you could say, check Snopes or PolitiFact first for this headline, and then you combine those search snippets with Gemini's reasoning in that grounded fact check with Snopes and Gemini function? That sounds way more solid for real-time checks.
It really is.
Yeah.
This function pulls snippets from general search and specifically from sites like Snopes, PolitiFact, related to the claim. It then formats these snippets nicely and feeds them to Gemini as context in the prompt. The prompt asks Gemini to summarize the evidence, analyze if it supports or refutes the claim, give a verdict, True, false, misleading, lacks evidence, explain why, and even rate its confidence.
Wow. So you're not just asking its opinion, you're giving it evidence, fresh search results, and asking it to act like a fact checker, weigh the info, and justify its conclusion. Seeing that applied to live headlines on different topics really showed the potential power.
It's exactly. Grounding the LLM with up-to-date search results, especially prioritizing trusted sources, makes the fact-checking much more accurate and reliable for breaking news. It moves beyond just finding similar static texts to actively investigating current claims using the live web.
So looking at this whole pipeline embeddings, RA, grounded live search, what really stand out as the biggest strengths of this combined approach?
Well, several things. First, accurately finding relevant existing fact checks using semantic search is a massive win. Second, grounding the LLM's response in actual evidence, whether from a dataset via RA or live search, drastically improves factual accuracy and cuts down on AI errors. And third, the flexibility from prompt engineering lets you shape the output from a simple verdict to a detailed, structured explanation.
And the flip side, what are the limitations or maybe weak spots in this kind of system right now?
Yeah, the research flagged a few key things. The initial reliance on a static data set means it might miss brand new claims until updated, which really underlines why that live search grounding becomes so important. There's always a risk of bias, too, either from how we write the prompts or biases within the search results themselves. And currently, it's mainly English-focused. Getting it to work well in other languages is a big next step.
It definitely sounds like a super promising way to use AI against misinformation, but yeah, still evolving, lots of room to improve. So bringing it all together, what's the main takeaway you want listeners to get from this deep dive?
I think the core message is the power you get when you combine these different AI techniques. Embeddings give you meaning, vector stores give you speed, and LLMs, when properly grounded with reliable sources, be it curated data or the live web, can generate genuinely insightful, evidence-based explanations for these really complex misinformation challenges.
And it sounds like the future development possibilities are pretty exciting too. You mentioned multi-language support, better user interfaces like web apps or chatbots, maybe smarter ways to filter search results.
Absolutely. This is really just scratching the surface. As the tech evolves, these fact-checking tools will likely get more sophisticated, more integrated into how we experience information online, and hopefully play a really positive role in navigating that complex landscape.
This has been seriously fascinating, really digging into how AI might help us wrestle with misinformation. It definitely makes you think about, well, the future of truth online. Thanks so much for walking us through all this.
My pleasure. It's a really important area, and it's encouraging to see how these tools could potentially make a difference.
And thanks to you, our listeners, for joining us. We hope this gave you some food for thought on how AI is tackling this huge challenge. Until next time, keep questioning, keep learning, and stay curious.